Welcome to the 8th tutorial session of problem solving through programming in C. So this is a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSE, IIT Kharagpur, and I am Siddhant. I am the TA who is in charge of taking these tutorial sessions where we will discuss the particular week's contents, and we will also solve a few questions which will probably help you out with the assignments and with the final exam. So in week 8 that we will be looking at, we looked mostly into functions, like what are the how to pass variables to a function, and also a concept called recursion, which is very closely related to the concept of functions. So we will solve a few questions with respect to each of them. Feel free to unmute and answer or ask doubts, or you can also write it in the chat box. So let us start the session. So now functions basically it is a block of code, right, which will solve a particular purpose. Now main is also a function, that is where the main function is where the code execution starts. Now just having that much of idea about the functions, and also I am assuming you might have watched the week 8 lectures already. So let us directly jump into solving some questions. Okay, so the first question asks, what is the output of the following C program? So we are declaring two functions called foo and f. So this is basically the function prototype that we are declaring. Okay, we are declaring that we will be using these two functions of void type somewhere in the code. Okay, we just in order to like whenever you are defining the function prototype before the main, that basically is to tell the compiler that we are going to use this function later on. Okay, so yeah, so let's then we have a int main, the main function. This is where the program execution will start, and inside the function it calls the function f. Okay, now as you can see in the function f, it's a function of void type. It will print something and it will call the function foo, and then the function foo prints 2. So void type basically means that it does not return any value, okay, to the calling function. So here the calling function is the main function, and we have called the function f from there, but the f is not going to return any value to the main function. Okay, so that is why it's a type void. Similarly, in the f function we have called this function called foo, and this function is also a void type because it is not really returning any values to the function f. Alright, so what should be the output of this C program?
Option B.
Option B or D? What did you say?
1 and 2.
Okay, 1 and 2. Okay. So yeah, so others agree to that. So yeah, the answer will be option B, which is 1 and 2. So first you can see that this is the execution. Basically how the execution takes place is something like this. Okay, so first the main function, the execution always starts on the main function. So the main function is called. Now you can see that the main function calls the function f. Now if the f function is called, then first what we are doing is we are printing out something, and then we are calling this function foo. So 1 is going to be printed first and followed by a space. Then the next line it calls the function foo. Now foo will print 2. Okay, that is all that function will do. So then 2, and then what will happen, After doing this, the control of the program will come back to f. Okay, and as you can see, after the foo calling statement there is nothing else, so it will also the program will go back from f back to main, and then after saying this function call, which is the function call of the function f, as you can see there is no more statement here, so it will just exit, the code will exit from there. So this is how the execution will take place. First the main will be called, inside the main the function f will be called, f will print 1, and then it will call the function foo. The function foo will print 2 and then return the control of the program to function f, and function f, as you can see, no more statements after calling the function foo, so it will send the control of the program back to the main function, and in the main function as well it will, after this it will exit. Okay, because there is nothing, no more statements after this function call of function f, so the code will exit. So the output of this code will be 1 and 2. Right? Is there any doubt as to how the flow of the program goes here? Okay, so let's look at the next question. So this question is related to the scope of a variable. Okay, this is that like this question is related to that. So what will be the output of the following code? And you have a, so if you are defining any variables outside the main function, outside any of the functions, okay, so after the preprocessor directives or even anywhere between, but not in any of the functions, if you are defining any variables outside the functions, those variables are called global variables. Okay, they are called global variables and they can be accessed by any of the functions. Okay, so this, now I has been defined as a global variable with the value of 15, and its value can be accessed from any of the functions that you have written, main function, this function fun, and whatever other functions you have. You can access the value of this I because it's a global variable which is accessible to all, the value of I is accessible to all the functions. Okay, now next what I do is I write int fun, which is basically again the function prototype. So that means I'm telling the compiler I'm going to use a function called fun at some point which will be returning a int. Okay, that is an integer. Now I start the main function, I define a local variable. So any variable that has been declared within a function is a local variable. So this j is a local variable. Okay, now any function that is defined inside any variable that has been declared inside the function is a local variable. So this j is a local variable. Now we are setting j to the value of I, and then we are writing I equals fun, we are calling the function fun, and because fun will return an integer value, we need to store it somewhere, right? So I am setting the value of I to whatever is going to return from this function fun, and then I am going to print the value of I and j. So what does the function fun do? It initializes or declares a variable I, sets it to 25, and just returns the value. So what do you think should be the output of this code? Any guesses? So what happens here? 25, 15. Okay, let's see. So first what happens here? So j is set to I. Okay, so before this, if you see, before this the only definition of I is that of the global variable which has the value of 15. Okay, before this statement int j equals I, the value of I has never, so I is only known as a global variable so far, and it has a value of 15. So j will simply get the value of 15 from that global variable I. Okay, now the next statement says that you are calling the function fun and saving the value in I. So as you can see, there is I has still not been initialized inside main, so this I will still affect the value of the global variable. So this is still referring to the global variable I. Okay, this refers to global variable I still, because you have not initialized the value of I, or you have not declared the value of I inside the main. Now what happens inside the function fun? So inside function fun, you are initializing, or you are declaring a I which is set to 25. So this I is actually local to the function which is fun. So you are defining now a variable I which is local, because you are declaring this. You are writing int I equals 25. If I wrote only I equals 25, that means it would have again changed the global variable. But I am redeclaring the variable I. I am saying int I equals 25. So now this I is completely different from the global I. So this I is a local variable which is local to the function fun. Now I am setting this local I to 25 and I am returning that value. And that value is going to be stored where? In the global I, because that is where I am storing in the main function, which is calling the function called fun. So here what I am saving, the value that is coming from the function fun, I am saving that to the global variable I. So now the global variable I becomes 25. So this is the global variable I, okay, that becomes 25, which comes from the function called fun. Now when I am printing it, so here also this is, so far I have not declared any I inside the main function. So as long as I have not declared another I inside the main function, this will still, whenever I use I, it will still be the global variable. Okay. Now here the global variable, when I want to print I and j, so here it will print the global variable of I. The global variable I, what value does it have currently? It has 25, right? And what value does j have? 15. J is 15, because that is what it was saved initially. We have not changed the value of j after that. So 25 comma 15, that is what is going to be printed. Is it clear?
Yes, sir.
Okay. Anyone has any questions? I couldn't hear, someone was saying something. No? Alright. So then let's move on to the next question. Alright, so what we have here is, it asks what is the output of the following code snippet. Now we have a function called swap. It is a function of void type. It takes two integers. What it does is it swaps the values of the integers, and then we write the main function. So you can see I have not really written the function prototype here. Why is that? Because I am directly writing the function itself. So the function prototype is, so here I had defined the function prototype, right? The function prototype is only required when you want to write the functions after it has been called. Okay, so for example, here I am calling the function f. So the compiler needs to know that there is a function f that I have defined, because the execution will start from the main function, right? So if the compiler does not know, I have not written this function prototype, and the compiler does not know that there is a function f, then it will throw an error. So you need to tell the compiler beforehand. If your function, if I wrote this function f before the main function itself, then I could have used, and then the foo function I would have to write before f itself, because now for the same logic is applicable for that. So when it comes so before the main function I would have to write the f, and before the f I would have to write foo, because by that time the compiler would already have, it would already have data about the function foo. So here when the f is executed, 1 would be printed, and after that it would search for foo. But foo, if you have not written the function prototype, it does not really recognize what foo is, because it's a user defined function. There is no library function called foo. Now that is why you have to define the foo function before the function f, and then the function f before main function, if you don't write the function prototype. Okay, but it's easier to write the function prototype, just to say what kind of function it is. Just write the function prototype, and then you can define the function in any order you want. If you have written the function prototype, then you can define the functions in whatever order you want. So it is an easier way than seeing all these relations where so basically every function has to be defined before the function where it is being called from. So rather than maintaining that kind of strict adherence to the flow of logic in the code, it's just easier to write a function prototype. Okay, I hope you're clear why function prototype makes sense. Alright, so let's go back to the question. So this is a function called swap, which is of void type, so it doesn't return anything. Now it takes two integers and exchanges the values and swaps the values of the integers. Now in the main function, what we have is we are defining two integer variables x and y, setting the value to 1 and 2. Now we are calling the swap function with x and y, that is with the values of 1 and 2, and now we are printing the value of x and y. So what will be the output of this code snippet?
X equal to 1 and y equal to 2.
Okay, why do you think so?
Because x and y are localized to main function.
Mm-hmm.
And it is not getting changed as swap function.
Yes, you're close. So basically what is happening is these are the actual parameters that you are passing. Okay, these are the actual parameters or the actual variables, that is x and y, right? Now when you pass it to, and these are called the formal parameters which you write in the function. Now it happens something like this. This is your memory space. You have some x and some y, and when you call this through the swap function, this a and b are actually at some different memory location, and the value just get copied. So this has a value of 1 and this has a value of 2. So this value will get copied here and this value will get copied here. So that is what will happen. So any change you make to the values itself in a and b will not really affect x and y. Okay, because x and y are basically different memory locations, and here this is only swapping the values, right? It is only swapping the values of a and b, which are actually different memory locations than x and y. Okay, so what it does, it becomes from this to this. This is x, y, 1, 2, and this is a, this is b, this is 2, this is 1. So this is what will happen. This will become 2, that will become 1. Now this is what this function swap will do. But because it's a void type, it is not even returning anything. So x, y still remain as 1 and 2. So here when you try to print x and y, even after the swap function, the value of x and y will still be 1 and 2. Now what would you have done if you wanted to actually swap the values of x and y? How could you change this function? Any suggestions?
Pass the pointer value.
Exactly. So instead of doing this swap of x and y, I would have sent the location of x and y. Similarly here I would have written void swap int star a, int star b. So it becomes basically now the memory location I am passing. Okay, and then I would have swapped the memory locations. So in this case, basically what would have been created is you would have a x and y, but a and b, so this has value of 1 and 2. Now I am saying that a is a pointer to x and b is a pointer to y. That is what would happen. Now when I swap the pointers, now in what would happen is I would say now b points to, wait, just a minute. Okay, now now a points to x and b points to y. Now if I had changed, if I had said no, okay, now I am going to set the value of whatever this, okay, so let me write like this. So TMP equals star A. I'm saving the value what is stored in A in TMP, okay, so some I into TMP, and now I'm saying that star of A will be star of B, okay. Now the next step, star of B equals TMP. If I do this, then what happens? So you're saying that the value of A, so A is pointing to X, okay, and X has a value of 1. So now I'm saving this value 1 in this variable TMP. Next, what I'm saying is the value of B will get stored in the value of A, and here that means what it means is that the value that B is pointing to will actually get copied to the memory location that is being pointed by A. So this will cause the values, and then what next step is star B, which is the value that is being pointed by B, will have the value of TMP, which is 1. Okay, so now this will change it to something like this. Okay, so this will become 2, this will become 1, and still you will have A pointing to this and B pointing to this. But actually a swap has occurred now because you pass the memory location of the variables instead of the values, and you try to swap the values based on the memory locations themselves. So you are actually able to swap them. Is it clear?
Yes, sir.
Okay. Alright, so basically this is the difference between call by value. That means the one that this example follows is call by value, and this is called call by reference, because we are passing the reference, that is the pointer to the memory location. We are passing that, so it's called call by reference. Alright, so let's look at the next question. So what will be the output of this particular C code? We have a char variable. Keep this in mind, a char variable. So this is not particularly like a functions thing, it is more of a miscellaneous question. So it is char variable x set to 0, and then we are running a for loop from 0 up till 127 with an increment of 1, and we are printing %d, that is the integer. Okay, we are printing it as an integer, what? The value of x. So what should be the output of the code? Option A. Okay, so this there is a catch here actually. Why I said that? Keep in mind that it's a char variable. So char variable, basically what values can it hold? Minus 128 to 127. This is the range for char variables. Okay, this is the range of values that they can store, minus 128 to plus 127. Now you have a char variable set to 0. Okay, now you are simply from 0 to 127, it will simply increment and keep printing, right? So 0 to 127 is pretty clear that it will be printed. So 0 to 127 will be printed. Next, what happens when we do a plus plus? So after this x equals 127, the iteration after that, so at the end of the iteration when x equals 127, what happens? So if we look at x equals 127, this iteration, okay, what happens at the end of the iteration? X plus plus causes x to become 128, but x cannot actually become 128, right? Because x is a char variable. Char variable can have only a range from minus 128 to plus 127, but you are doing an increment, so ideally x should be 128, but it cannot be 128. Okay, this is not possible. So instead it will roll over, the value will instead get rolled over and it will become minus 128. Okay, after when you are at 127 and you increment x, do a x plus plus, the value will roll over and become minus 128. Okay, now minus 128, when you see it, it satisfies the condition, which is less than equal to 127. Of course it's less than equal to 127, so it satisfies the condition. So next you will have minus 128 being printed. Then again you will do a plus plus, minus 127, and so on. So this will continue. Again you will reach, at some point you will reach 0, and you will again proceed to 127, and again the value will become 128, but it cannot, so it will become minus 128, and again this will continue in a infinite loop, right? So answer will be option C here. Is this clear why the value became minus 128 and how it will be an infinite loop? Is the idea clear?
Sir, will this be true even for integers for x is equal to
Yes.
2 power 63?
Yes, it will be true for any kind of variables. Char was used here because it has a very small range, so you can see the values easily, but it is true for any of the integers, like any of the data types. It can only take value, save value within its range. If you try to save a value outside its range, it will just roll over its range. Okay, so that is true for all data types. Is that any other doubts? Okay, so now that this is clear, let's go to the next question. So this is more of a theoretical question. So what is the error in the following program? So the program is saying there is an error already. So we are defining a function f which is of type int, taking an int as an input, and basically we are writing this conditional operators. If you remember ternary operator, this is a ternary operator. That means it is operating on 3 operands. The first is this condition, which is a greater than 20. The second is return 10. Third is return 20. Okay, so this is the if part and this is the else part. Okay, and this is the condition. All right. Now in the main function, what we do, we define b, like we declare a integer b. We set b equals f of 20, and then we print b. Okay, so b equals f of 20. So we are passing f of 20 to, so a value of 20 to this function. So what should be, if there is an error, what is the error? If not, what do you say? So basically what happens here, so I would really say that there is an error here. There is an error. Now what is the error? That you cannot write a if statement, a return statement with conditional operators. So the error is actually option A. You could have written, instead of this, you could have written if a is greater than 20, return 10, else return 20. This is a legal syntax. Okay, this syntax has no issues, but this is a illegal syntax. So the problem lies with the ternary operators, the conditional operators. So you cannot use return statements with conditional operators. Okay, so that is the error. If you want to use it with a condition, you write the entire if else statement in the if else format rather than using a conditional operator. Okay, so that is the error in this code. Okay, now if you had written it in this manner, what would have been the output here? If you had written it in a if else statement form, right, then the value would have been 20, because you are sending the value of 20 here. A greater than 20 is not satisfied, so it will go to the else part, it will return 20, so that means that value will get saved in B. You will have B equals 20 here, okay, in this case. All right. So, okay. Now, this is the next program. Next question. So we have a function called func, and it is taking an integer num as input. We are setting a count, that is a integer a variable count to 0 initially. Where we are saying while num, that means this program will run until the value of num becomes 0, right? If num becomes 0, then the while loop will stop, but until then, if num is non-zero, it will keep on going. Now we are incrementing the value of num, and we are doing this. What is this? It's called the right shift operation. It's a right shift and assignment operation that we are doing. Okay, this basically means that num equals num right shift 1. This is what it means. It's a shorthand notation. Okay, so what the right shift operation does is that it shifts all the binary digits. Like if you convert whatever number you have to binary, it will shift everything by, you have said by 1 unit, so it will move everything by 1 unit towards the right. I'll show an example. But what effect does that have is that num, if it is 60 and you do a num of right shift by 1, the value becomes 30, because you lose, it will be divided by 2. You can figure it out why. That is pretty interesting. There is a pretty interesting way to do a division. Okay, but it will divide it by y, divided by 2. Okay, now let's first convert this. So this will be 217, right? So value of 1. So remainder is 1, right? Now again, if I divide it, so it will be 108, right? No? So still remainder of 1, right? Then 54, remainder of 0. 27, remainder of 0. Then 13, right? Remainder of 1. Then 13 will be 6, remainder of 1. 3, remainder of 0. 1, remainder of 1. 0, remainder of 1. Okay, now we go all this way. So basically this 435, if we convert, it's in decimal, we convert it to binary, so what it will be, 1101 10011. This is the binary notation for 435, right? Pretty straightforward. Just divide it by 2, take the reminders in the opposite direction. All right, so now what this right shift, when I say 435 right shift by 1, what value, like what happens exactly? So everything gets right shifted by 1, so this last bit is lost. Okay, that it goes away. Now I right shift everything, so this, I'll start from this 1. So before that are 2 zeros, 2 ones, 1 0, 1 1, and this will be 0 because it now does not matter, no value there. So this will become this. So I have right shifted all the binary values by one place. Okay, so that is what this will do. If you calculate this back to decimal, so if you calculate this back to decimal, how do you do that? You will multiply 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. You will multiply with each of the corresponding values, and then you will add them up. So if you do that, so I'll again write this down. So this is 1 into 2 to the power 0, 0 into 2 to the power 1, plus 0 into 2 to the power 2, 1 into 2 to the power 3, 1 into 2 to the power 4, 0 into 2 to the power 5, then 1 into 2 to the power 6, 1 into 2 to the power 7, plus 0 into 2 to the power 8. So this is what you will do. If you calculate this, the value will come out to be 217. Okay, so what does that mean? So basically it's the same thing, it is discarding the remainder. It is not caring about the remainder. You are dividing and you are taking the quotient only. That means this operation, whatever it is doing, it is discarding the remainder, it is taking the quotient only. This was not clear from the example, right? Like it had an even number, so we could see that it was dividing it by 2, value of 30. But now this is an odd number, which is 435. So we got to know that if you do it on an odd number, you will get only the quotient part. Okay, the remainder is just discarded. So keeping that in mind, let's now look at this question. So first we call the func function with the value of 435. So first iteration, okay, iteration 1, or the first iteration, the count value increases by 1, so it becomes 1, right? And okay, let me write it in a different format, which will be a bit more compact form. So I'll write the iteration here. Okay, this will be my iteration, and yeah, the count value will be here and the num value will be here. Okay, so iteration 1. So what happens in iteration 1? Count becomes 1, right? Count was 0 earlier. Num was 435, num became 217. Alright, now num is still positive, so while loop will still run. So it's non-zero, so while loop will run. Second iteration, count will become 2, this will become 108, right? Third iteration, count will become 3, this value will become 54. Iteration 4, count will become 4, this will become 27. 5, this will become 13. 6, this will become 6. 7, this will become 3. 8, this will become 8. Count will become 8 and number will be 1. 9, this will become 9 and num will become 0 finally, right? Now if this is the case, after this, in the 10th iteration, does not really happen because num has become 0 now, so this condition becomes while of 0, which is now false, so it will go outside the loop. So if it goes outside the loop, what is the value of count here? 9. Yeah, so 9 is going to be the answer here. Is it clear how this code runs? Any doubts here? You can also write your doubts in the chat box. Okay. Alright, so now if this is clear, let's go to the next question. So now we are going to start recursion. So recursion is basically a concept where we call a function from within itself. Okay, so that's when we call it's a recursive function. That means you are calling the function from within itself. So what does that mean? So for example, you have this function called func here, okay, and then again you are calling the function func from within itself. So you are writing a recursive function here. You are introducing a recursion here. Alright, now the recursion questions can be a bit tricky, so we have to be a bit patient and careful while solving these questions. Okay, now let's look at this. So what will the function return? So we have a function called func with taking two integers x and y, and we have a few return conditions. So basically always you will find for any recursion functions you will have this kind of conditions, say y equals 0, y equals 1, some condition where the recursion has to stop. So this kind of condition is required, okay, for the recursion to stop. So at some point the recursion needs to stop, right? So this is the point where the recursion will stop based on these conditions that you write, the recursion will be stopped. These are the stopping conditions for the recursion. Okay, now the recursion, if these two are not satisfied, like y equals 0, y equals 1 is not satisfied, then in the most general case it will return x plus, then it will call itself with a value of x comma y minus 1. Alright, so now what the question is asking is that what will the function return. So we have a few options here. You can see that there are two possibilities, x plus y and x multiplied by y, and x and y can be either like positive or negative integers, or it can be particularly non-negative integers. So let's start with the most special case, which is non-negative integers. Okay, so I'll just take some random values. First I will take a value, say x equals 2 and y equals 0. Okay, so what will be that? What will be the return value from there? If I call the function func with 2 and 0, what will be the return from the function?
0.
0, right. Now similarly, if I write 2 comma 1, it will return
2.
Right, it will return 2 because y is 1, so it will just return x, so it will return 2. Now if I write func 2 comma 2, what will that do? That will not satisfy these two equations, so it returns 3 plus something. Okay, so let's write that. So x is 2. Now it will call func 2 comma y minus 1. Y minus 1 is 1, and this returns what value? This returns a value of 2, right?
2.
So this entire thing will become 4. Okay, now if I do 2 comma 3, what happens there? So 2 plus func of 2 comma 2, this will again do 2 plus func of 2 comma 1, and this is 2, so this will return a value of 4 here, right? Value of 4 will get returned here, and this will again add up to 6, so this will return a value of, right, and this part will return a value of 6 here. So now we can see that it is basically multiplying the values. Okay, so now our options are either A or B. So far we have checked with only non-negative integers. Now let's check with some negative integers. What happens with negative integers? So we'll take, say, x, let it be 2, y I am taking at, say, minus 2. Alright, now here what will happen? It will write 2 plus, it is not satisfying the condition, so 2 plus func, it will call the function func again, 2 comma minus 3, right? And this will again call, this will again be 2 plus func of 2 comma minus 4. So you can see what is the issue, because we are written a minus 1, it will go on, if it is a negative value, it will go on becoming more and more negative. So this will cause a recursion till stack overflow. So this will keep recursing over itself till a stack overflow happens. Okay, so this will keep on infinitely recursing. Alright, so basically we cannot use negative integers. Okay, so the answer would be option B. But depending on, like, here the options are non-negative integers, but if you look carefully here, the strict, like the proper answer here would be x can be any integer, okay, but y has to be greater than equal to 0. Like y has also to be an integer, but greater than equal to 0. So why I am saying that? Because it has nothing to do with x, because the value of x is only getting passed as x, so decrement is happening on y. So if y is positive, then everything is fine. So even if x is negative, you will still get the product, but if y is negative, you will never get the product. Like it will infinitely do the recursion until the stack overflows. Okay, so this is actually the strict adherence of what this x and y values can be, but it will return the product of x and y. Okay, but here according to the options we will just take non-negative integers. X and y are non-negative integers, only then it will return x into y. Okay, is it clear?
Yes, sir.
Okay, so now we'll look at another question from recursion again. So the rest of the questions that I have are based on recursion, so it will the solutions we have to do it a bit carefully. So we are defining a function fun, which is taking an integer. The condition, like I said, there would be a stopping condition for every recursive function, right? So here the stopping condition is if n is less than equals 0, it will return 0. Now in the general case, it will return n plus fun of n minus 1. Okay, so in the main function what we do is we define a variable called result and we call the function fun with the value of 10. Then we are printing the result. So what should be the value of this? So let's try to solve this. So we are calling fun of 10. Okay, so that does not satisfy the condition, so it will basically try to return, so we have the main function, say it will try to return something, but what is that something? N, that is 10 plus fun of 9, right? So now what is the fun of 9 again? So the fun of 9, it will try to return to this, right? To, or rather, let me okay, so fun of 9, basically what it tries to do, so it will try to get the value of 9 plus fun of 8, right? This will try to get the value of 8 plus fun of 7. Similarly, 7 plus fun of 6, 6 plus fun of 5, 5 plus fun of 4, 4 plus fun of 3, 3 plus fun of 2, 2 plus fun of 1, right? 1 plus fun of 0. Now what is fun of 0? Fun of 0 satisfies this condition, so it will return 0. So this value is 0. Now the recursion continues till this many steps. Now it will come back. So this value is 1. That 1 will go back here. So 1 goes back here, right? So this value will become 3. 3 goes back here. 3 will become 6. So 6 goes back here. So 6 goes back here. So 6 plus 4, 10, right? 10 will go back here. 15, right? 21, 28, 35, 44. Oh, did I make a mistake somewhere? 35, this will be, okay, let me
36. 28 after.
Oh, okay, yeah, sorry. Yeah, that's 36. So that's 36. 36 will get returned. Now 36 will get returned, then it will be 45. So 45 will get returned here. That means 45 plus 10. What will be returned from this function? So it will be
55.
55 will be returned, right? So this the function fun of 10 will return 55 to the main function. So here, so 55 is going to be returned here. So the what will be printed here will be 55. So you see how recursion works. So this is basically a basic example of the recursion function. Okay. Any doubts here? No? Okay. Let's look at the next question. So here we have a function called get, and we are calling get of 6 from the main function. So how many times will the function get be invoked. Okay, so we have a get function and we are calling get of 6. So get of 6 we have called. Now what this get function does, it takes a value. If n is less than 1, then it will return what? Return nothing, return 0. So it is, you just writing return, so it will return 0. Okay, if n is less than 1. Okay, now if that is not the case, like n is not satisfied, like n less than 1 is not satisfied, it will return get of n minus 1, get of n minus 3. Okay, so it will call two functions. It will call itself with two different values, which is n minus 1 and n minus 3. Alright, now let's see how many times this get, when you call get of 6, how many times get function get invoked. Alright, now I'll make a hierarchical structure for this. So when we call get of 6, it does not satisfy this condition, so it will call get of 5, right? And then it will call get of 3, but we'll look at get of 5 because that is what will get called first. So in other words, let me say it like this, that just forget about this part right now. We are only looking at the first statement, which is get of n minus 1, which is get 6 will call get 5. Alright, now what will get 5 call? Get 5 will call get 4, right? Get 4 will call get 3, get 3 will call get 2, get 2 will call get 1, get 1 will call get 0, right? And this will be 0, so it will return back here with the value of 0. It will return back to get of 1. Now get of 1 will all, and after that what will get of 1 call? Get of 1 will call get of 1 minus 3, which is minus 2, which will again return back here, okay, because it is also less than 1. Now it will go back to get of 2. The control of the code will go back to get of 2. Now this was the n minus 1 part. Now it will return the n minus 3 part, which is get of 2 minus 3, which is minus 1. So this will also return, because this is also 0. It will return back here, and again it will go back to get of 3. So for get of 3, n minus 1 has been done. What will n minus 3 give? Get of 0, which will again be 0. So it will come back. There will be no further recursion across this. So it will come back here. It will go back to get of 4, which was, and the n minus 1 condition, n minus 1 get was already done. So the next will be n minus 3, which is get of 1. Now get of 1 will again go to, so it does not satisfy the condition, as you can see. It will call get of 0, which will again come back here, and then it will call get of minus 2, which will again come back here. Then after it comes back here, it will come back to get of 4, which will again come back to get of 5. So once it comes back to get of 5, the n minus 1 is done. It will call n of get of 2, because n minus 3, right?
Sir?
Yes?
Sir, once again, please explain, sir, this concept recursion. Can't it-
Okay, fine. I'll explain from the beginning. I think that's, yeah, this is a bit tricky. The exact order, if you want to follow the exact order, actually if you don't follow the exact order, still you can solve this question. But I was trying to explain to you the exact order in which the execution will take place. Okay. So this will call get of 5. Okay. This will be called get of 5. Now if I call get of 5, it will not satisfy this condition. What will it call? So it will call get of 4. Okay, it will call get of 4, right? Is that clear? Why it will call get of 4? N minus 1, right? So now what will this get of 4 call? Get of 4, if you run, then it will call get of 3. Now if get of 3 is called, it will return get of 2. If you run get of 2, it will it will call get of 1 till the condition is satisfied. It will keep getting called. Okay, now get of 1 will call get of 0. So now the condition is satisfied. The recursion will, for this particular loop, the recursion will stop here. So like n becomes less than 1, so it will return 0. Now this returned back here. Okay, what is the next statement? When get of 1 was called, what was the next statement? The first statement was get of n minus 1, which was 0. So what was the next statement after that? Get of n minus 3, right? So the get of 0 because n minus 1, right? So when get of 1 was being, when you are running the get with a value of 1, the first thing that will, yes, yes, if it is so the condition is that if n is less than 1, only then it will return 0. Okay, otherwise it will just go to the next statement and again call get with a value of n minus 1, and then after this part is done, it will call again get with a value of n minus 3. So that is why when you are running get of 1, say I put n equals 1 here. Okay, so what happens? This condition is not satisfied, so I call get of 1 minus 1, that is get of 0, right? But if I put a value of 0 here, when I call get of 0, what happens? This n is now less than 1, so it will simply return 0. So it will return 0. Now this is returning a value of 0 back to get of 1. Get of 1 called get of 0. Okay, that is what you need to remember. So it came back here. What is the next thing that it will call? Get of n minus 3. So what is the next thing that get of 1 will call? Get of n minus 3. What is n minus 3? N is 1. So 1 minus 3, it will call minus 2. Are you able to follow?
Sir, is n not updated in the previous call?
Sorry, which is not updated?
Is n not equal to 0
Where
here?
are you talking? N not equal to 0? Okay, no, n is not updated. No, it's so get of 1 calls get of 0. Okay, but the value of n here, n is a integer which is separate for each of these invocations of get. Okay, it's not the same. The n value is not the same for each of the invocations. So for each invocation or each instance of get, there is a particular n value. Okay, so if you have the get here n becomes 0, does not mean here n becomes 0. It does not, because you are not changing the value of n. You are actually decreasing, like you are passing a value which is with a relation with n. You are saying that whatever n was there in that function, I will pass n minus 1 again to the same get function. Okay, you are not really changing the value of n per se. So here get of 0 comes here, goes back to get of 1, right? Because it now satisfies this condition, it simply returns back. Now in the next step, what will happen? We will call it with a get of n minus 3. So n is still 1 here. That's clear, right? N is still 1. When we are calling get of 1, say forget about the rest of the part. Okay, I am saying that I am calling get of 1. Okay, if I am calling get of 1, this first condition is not satisfied. This will call what? Get of 0, n minus 1. That does not mean n's value has changed. It will just call get of 0. Now get of 0 returns back to get of 1. Now in the next statement, we call get of minus 2, because we do n minus 3. We don't do n equal to n minus 3. We do not do that, do we? We just do n minus 3. That means whatever, so 1 is the value of n, 1 minus 3 minus 2, that will be passed. Okay, so that is what we do. So the n value actually does not change.
Yes, sir, understood.
Yeah. So this comes back here. Now the next statement, what is the next statement? Get of n minus 3. So the get of 1 will call get of minus 2. So minus 2 also will return back here, because it will not do anything, because it is basically less than 1, so it will simply return to get of 1. Alright, now it returned to get of 1. So the role of get of 1 is now over. So who called get of 1? Who called the function get of 1? If you think about that, which function called get of 1? Get of 2 called get of 1 here, right? When I was in get of 2 instance, I had called get of n minus 1, so it had called get of 1, right? So if I return back the control to get of 2 from get of 1, this entire part I have done now. I have returned the flow of the code to get of 2. The next step would be to do get of n minus 3. So now get of 2 would call get of n minus 3, that is 2 minus 3, that is minus 1, right? Now get of minus 1, again n is less than 1, so it will return 0, so it will simply return back here. Okay, now after this returns back, what happens? So who had called get of 2? Okay, so because here n minus 3 is done, that means that particular code is done. N minus 3 is done, that particular function call is over, because there is no other statement after that, right? So that particular function call is done. So get of 2 is now done. I have checked the condition, it was false, so I didn't return anything. Then I called get of 1, and then there was a lot of function calls after that. So get of 1 returned the control back to get of 2. Then I called get of n minus 3, which was get of minus 1. Again that function call got over, and in the power came back to the control came back to get of 2. So now get of 2 is done, no further statements to do in get of 2. So the control will go back to get of 3, which had called get of 2. So get of 3 had called get of 2, right? So the control will go back to get of 3. Now get of 3 would have called get of 2 when it was doing n minus 1. So now next what get of 3 will do is it will call n minus 3, that is get of 0. Okay, now again 0 fulfills this condition, so the control will directly come back to get of 3 again. Okay, no further statements to do in get of 3. So get of 3 is done. It will send back the control to get of 4, which had called get of 3. Okay, now what does get of 4 do? Get of 4, this get of 3 was the n minus 1. So now it will do a n minus 3, which is still left to do. So it will do get of 1. So what does this get of 1 now do? If you run a get of 1, the condition is not satisfied, so it will first run now get of 0, right? So get of 0, because n minus 1, so get of 0 does nothing because it satisfies the condition, returns 0. So the condition immediately the control comes back to get of 1 again. Now get of 1 will again call who? N minus 3, so minus 2, and again condition fulfilled, control will come back here to get of 1. Now get of 1 has no further statements to execute, so it will send the control back to get of 4. Okay, now after the control comes back to get of 4, you can see that get of 3 has been done already, get of 1 has been done already, so no further statements in get of 4 to execute. So now get of 4 will go back or send back the control to which function called him. So the function that called him was get of 5. So it will send back control to get of 5. So for get of 5, get of 4 was the n minus 1 function. Now there is a n minus 3 function that it has to call. So now it will call get of 5 minus 3, which is get of 2. Now again it will be the same this part again. So get of 2 will call get of 1. Okay, get of 1 will call get of 0, the function will again come back immediately. Then it will call get of minus 2, the function will again come back here immediately. Then this will come back to get of 2 again, because get of 1 will be done. It will come back to the control will come back to get of 2. Now get of 2 has done the n minus 1 condition. Next it will run the n minus 3 condition, which is minus 1, which will immediately come back to get of 2 again. Now get of 2 is done. It has called the n minus 1, called the n minus 3, the control is back to get of 2. So get of 2 is done. So it will send back the control to the function that called it, which was get of 5. Okay. Now get of 5 is done, right? Because get of, okay, so get of 5, what it had to do, it had to do a n minus 1 calling, a n minus 3 calling. So it did both of that. It called get of 4 and get of 2. Both of them are done. Okay, no more statements to do in get of 5. So it will send back the control to get of 6. Now what will get of 6 do? So it has done the n minus 1 part. Now you will have a n minus 3 part. Okay, so n minus 3 part, what will it be? Get of 3. So this will be get of 3, because 6 minus 3. Now again this get of 3 will call the condition is not satisfied, so it will call n minus 1, which is get of 2. Now get of 2 will again call get of 1. Get of 1 will call get of 0, and here is where the condition gets satisfied, so it will just return back the control here. Then get of 1 will call 1 minus 3, which is minus 2. Again condition fulfilled, control returned. No further statements in get of 1. So get of 1 will just return to get of 2. Now get of 2 has done the n minus 1 case. It will now call get of 2 minus 3, which is minus 1. But this will return immediately because it satisfies the condition. It will just return. Now get of 2 has done all the statements. It has done the n minus 1, it has done the n minus 3. So it will return the control to the function that called it. It will return it to get of 3. Now get of 3 has done the n minus 1. It has to do the n minus 3, which is get of 0. Okay, this is 0. So this is get of 0. Now this get of 0, so n minus 3 n minus 3 calling. Okay, get of 0 still fulfills the condition. Simply it will return the power back to get of 3, which called it. Now get of 3, it has done the n minus 1, it has done the n minus 3, so it will return back. So it is done, no further statements. So it will return back the control to get of 6. So for get of 6, now both the n minus 1 is done, n minus 3 is done. So it will take the control, send the control back to the main function which had initially called it. Okay, we were calling get of 6 from the main function. So now the power, the control went back to the main function. So how many times did we call the get function here? Anyone
25.
Want? Okay, 25 times. So here I have actually drawn the complete schematic. You don't need the complete schematic. For example, once you do this get of 2, you know how many times the get function will be called when you write a get of 2, right? So you can do that. For example, here you can. Sorry? Get of 5. Okay. So get of 5. So any particular step here that you are doubtful with, like n minus 3. Oh. N minus 3. Okay. So n minus 3 for a particular gate or for all the gates that you want? So okay. So for any particular gate, say I just pick up this gate of 3. Somewhere in between I am picking a value. Okay, I think that will be a bit easier. Okay, so I'm just picking this get of 3. Okay, this one. Now it would have called n minus 1, and that called a lot of other functions, and the control has come back to get of 3, because get of 2, the entire part is done. So all of these things are done. So now the control has come back to get of 3. Okay, now for get of 3, when you call this function with a value of 3, get with the value of 3, so it had called get of 2, right, which had spawned all these different invocations of get. Now this statement is done, get of 2 is over. Now we need to run get of 0, because n is 3, so n minus 3 will be sent to the second statement. The second statement will result in a get of 0, which will, if you run get of 0, immediately it will come back, because it is a simply return 0. It fulfills the condition, so there will be return 0. It will just come back to get of 3 again. Okay, so this part for n minus 3 for get 3 is it clear how it happens? Now let's say for get of 4, what happens for get of 4? Now I'm looking at get of 4 here. So get of 4, this n minus 1 is already done. Get of 3 had sent back the power or the control of the code to get of 4, which had called get of 3. Okay, so now n minus 1 statement is done for get of 4. So next it will do the n minus 3 operation, right? So it will call get again with a value of 4 minus 3, which is basically the value of 1. Now this itself again has multiple steps, where it will call the n minus 1, which is again 0. Because it is 0, the power will immediately come back. No further invocations after that. Then after that,
again for n minus 1, because n minus 1 is done.
no, n minus 1 is done for which one? Like you have to see for which of the ones n minus 1 is done. N minus 1 has been done for get of 4 call. The n minus 1 has not been done for the get of 1 call here. So this get of 4, it calls n minus 3, which is get of 1. But so think of it as a completely new run of the get code with a value of 1. So in that case, you will again have a n minus 1, right? So each of these gets that you have, each of the times that you are calling get, it is a completely new get that you are calling. Okay, complete, like separate get invocation you are doing. Okay, it's not related, nothing related to the previous times that get has been done. So every time you are calling this get function, it is a complete new get that you are calling with a certain value. Okay, so that is why here get 1 will call its n minus 1, and then after the n minus 1 returns back control to get of 1, it will call n minus 3. Now that will return back to get of 1, and get of 1 has nothing else to run now, so it will send back the control to get of 4. Now for get of 4, now you can see that n minus 1 is done, n minus 3 is done, so no further statements in get of 4 to run. So get of 4 will return back control to get of 5. And now get of 5, for get of 5 this n minus 1 is done, which is get of 4. Now it will go to the next statement, which is get of n minus 3, which is get of 2. Now again the same thing will continue for get of 2. It will return back control to get of 5. So is it clear? Like roughly is it clear? You can try this by yourself. Yeah, you can try this by yourself and understand how, if you write it like step by step instead of doing this, don't directly go and make this schematic, but rather I would say that you can just simply write it like this: get of 4 calls get of 0. Then you write, it will not call get of 0, it will call, say get of 2. Okay, let me just write a small part of it. Just write it like this: say get of 3 will call get of 2, then get of 2, if you run a fresh get with a get of 2, it it calls what? It will call get of 1, right? Now if you run again a fresh get of 1, it will do what? It will call get of 0. Now get of 0 returns to get of 1, because it's the return condition is there, it returns to get of 1. So just write it like this, okay? It will be pretty long if you write it like in this manner, but you will be able to understand what exactly is happening, like the flow that is happening, you will be able to understand that if you just simply write it down for your own understanding, okay? Then you can try to make the schematic, and then you can even try to take shortcuts in the schematic. For example, here I have done for every get of 2, I have again done it again and again. So here I had done for get of 2, here again I did for get of 2. So if you have done once for get of 2, you know how many times, if you call get of 2, how many times the get will be called, you just know that. So I will directly consider that many calls from here, because the question asks for how many times it is being called. It is not really asking for what value will be passed or whatever. Okay, so you can take some shortcuts if you want. So this is like, try to get it step by step. Okay, all right, so just try this on your own again. Anyway, you will get this PDF. Okay, now let's look at the next question. Okay, now this is probably, the earlier question was the most difficult one among all that I had. Now these are easier questions, but still we have to be careful because there are calculation involved here. Okay, so we have a function called f, which takes n and k, two integers, as input. The stopping condition for this function, for this recursion, is if n equals 0, it will return 0. Now if that is not the case, and n percentage 2, so that means n percentage 2 is 0, sorry, n percentage 2 is non-zero, only then this else if part will run, right? If this part is anything other than 0, only then it will be true, right? That means what? If n percentage 2 is non-zero, that means it is odd, right? If it's an odd number, then it will call itself with the value n by 2 and twice of k, and added with k. Else it will call itself with n by 2 and twice of k minus k. So this is the case if it's even, this is the case if it's 0, this is the case if it is non-zero. Then if it is odd, then it will return this, okay, and if it is even, it will return this. Now we are calling f with a value of 20 and 1 from the main function. So what will be the output of this? Let's try to do this. Okay, 20 and 1 doesn't satisfy n equals 0, so this is n, this is k, okay, n comma k doesn't satisfy n equals 0, and it is even. So for even, it will go here, right? So what happens? It will try to return f of n by 2, which is 10, comma twice of k, which is 2, minus k, which is 1, right? Now it will call 10 comma 2, right? So what is 10 comma 2? Like what is function? What will this function call be? So again, it is even. It is not 0. It is even. So it will be again this else part, 5 comma 4, because twice of k, right? And here k was 2. Okay, this for this call, this function call, which is f, for this instance, n value was 10 and k value was 2. So here twice of k will be 4 and n by 2 will be 5, right? Minus k is 2, right? This was twice of k, this is k, minus k. Now this function call, what happens here? So 5 comma 4, still n is not equal to 0, so this is n, this is k, right? So for this function call, what happens? It is now odd. Okay, n by 2, it is an integer, so we just ignore the decimal part. So n by 2, 2.5, it should be 2.5, but it will be 2, comma, what is our k? K was 4, so now it will become 8, but plus, so you get what I am trying to say, twice of.
Sir, how did k become 8?
No, it does not, k does not become 8, twice of k we write as 8, so k is still 4. Okay, I misspoke. So n was 5 and k was 4 for this function call, and now it is calling the function with the values n by 2, which is 2, and twice of k, which is 8, and then adding with k, which is 4. Is that clear?
Yes, sir. Yes.
Okay, now what does this do? Now this, again, it is, n is still non-zero, okay, but it is even. If it is even, then the last statement, which is n by 2 and twice of k, so k is 8, so twice of k is 16 minus k, which is 8. Okay, now again for this, what does it call? So 1 comma 16, f of 1 comma 16, what is it? Still non-zero, but it is odd, so the else if part, so n by 2, now it becomes 0. Okay, twice of k, so k was 16, 16 into 2, 32, plus 16, right, plus k plus 16. Now what does this do? So f of 0 comma 32, this is simply 0, return 0, right? So instead of writing like this, I will say this will come back with the value of 0. Okay, so this value is 0. Now if this value is 0, this value is 16, right? This value is 16. So this will return, this entire part will return 16 here. Now if this returns 16, 16 minus 8, so becomes 8, right? So this will return 8. So this returns 8, 8 plus 4, 12. So this returns 12. 12 minus 2, 10. So this part returns 10. Right? Now 10 minus 1, 9. So this returns 9. So when we call f of 20 comma 1, finally what is the value returned to it? 9. 9 is the value that is being returned to it. So our answer will be 9. Is it clear? So is it clear how this recursion is happening?
Yes, sir.
Okay. All right. Okay. Then let's look at the next question. So it is basically it is written in a pseudocode kind of fashion. So it is a function called fun, which takes an integer x, and if x is greater than 100, then we say that fun is x minus 10. So simply it returns a value, okay, x minus 10. Otherwise, if it is less than 100 or less than equal to 100, actually, if it is less than equal to 100, else, okay, fun is fun of x plus 11. So you can see it is calling itself twice. Now you are taking an input of 95. So let's see what happens here. What value it will be. Do you want to calculate it on your own? You can try. Okay, so
Sir, what is that fun identifier mean?
sorry, fun identifier means
Means it is returning.
Yes, so this is the return state. This is return. This is basically same as return of x minus 10. Okay, so like basically yes,
How do we return the function in a program, sir?
yeah, like this particular function has been written in pseudocode. So like you can basically consider this part fun equals x minus 10 as return of x minus 10. Similarly, this statement will have a equivalent of return of fun of x plus 11. So this would be how it is, like these two statements. Okay, so that would be how you would write down this particular function. So if I want to write this entire function, I can write the entire function here for this. So the way that it is written, let me write that down. So you have int fun int x. Okay, you start if x is greater than 100, then return x minus 10. Okay, else return fun of x plus 11 and function over. So this is basically its C. If I write the function in C, this is how it will look like, this particular pseudocode. Alright, so now for the input of x equals 95, let's see what happens. So we call fun with a value of 95. So it will come to the else part because it's not greater than 100. So it will come to the else part, right? So in the else part, what does it want to return? It wants to return fun of x plus 11, which is 106, right? So now what is this 106? What is 106? 106 is, if you call
96.
exactly, so it's 96, right? Because it is greater than 100, so it will simply return x minus 10. So 106 minus 10, 96. So 96 will be returned here. So now this will become fun of 96. So the inner part is 96. So fun of 96. What is fun of 96? So now when you say fun of 96, so again it's not greater than 100, so it will call fun of x plus 11. That means 107. So what is fun of 107? 97, right? If you call fun of 107, so it will simply return, because x is greater than 100, so it will simply return x minus 10, which is 97. So now this will become fun of 97. Now fun of 97, what is fun of 97? So fun of 97 is, it does not satisfy this condition, so the else part again it will call. So fun of 108. So what is fun of 108? Fun of 108 is 98, right? Because if you call this function fun with 108, you will simply have 108 minus 10, which is 98. So now it will evaluate fun of 98. So how does this work? Fun of 98. So fun of 98 will again try to call fun of 109, right? What is fun 109? 99. So this will become fun of 99. Now this fun of 99, what does it call? It calls fun of 110, right? So 110, what does it become? 100, right? If you pass fun of 110, let me put this in a separate, if you pass 110 to the function fun, so you will have 100 being returned to you. So this is basically the same as fun of 100. Now if you are saying fun of 100, it still does not satisfy this condition, so it will call fun of 111, right? What is 111? 111 is 100 and fun of 111 is 101 because x minus 10, so 101. So this is basically fun of 101. So what is fun 101? Fun 101 is 91, right? So this will return 91 where? It will return 91 to the function that called it, okay? That was fun of 100, okay? So this entire value, this fun of 111 came out to be 91. That 91 value will go where? 91 will go to fun of 100, which called this fun of 111. Okay, now this 91, it returns back to this function, but who called this function? So fun of 100 was what exactly? It was fun of 110, and who called this fun of 110? It was called by fun of 99. So the 91 value will go back to fun of 99. And how did fun of 99 come out to be? It was fun of 109. So who called that fun of 109? Fun of 98. So this will go back, the 91 value will go to fun of 98. And who called fun of 98? Fun of 98 was basically fun of 108. And that was called by fun of 97. So the value will go back, 91 value will go to fun of 97. Now similarly, that was fun of 107, and that was called by fun of 96. So the value 91 will go back to fun of 96. Now what was fun of 96? Fun of 96 was fun of 106. And who called that? It was fun of 95. Fun of 95 called fun of 96, right? Fun of 106. So the 91 value will go back to fun of 95. So basically, if we put fun of 95, your answer will be 91. Is it clear? Any doubts here? So in each of these cases, the inside this fun, whatever.
Sir, what is recursion?
Recursion means calling the same function from within itself. So this is a function called fun, and it is calling the function itself within its code. It is within its block, it is calling itself. So recursion functions you have to resolve in this kind of way. So the flow will happen in this kind of manner. The flow of control in the code will go in this manner that I have described in this question. All right. Okay. So the next question is a programming question. So it's C program to enter an integer and convert to octal using recursion. So basically you are entering a decimal and you are converting it to octal. Octal meaning it will have digits from 0 to 7, right? It's a base 8 number system. So our integer is a base 10 and octal is a base 8 number system. So how do we usually do this? Any clues?
Division by 8 and getting the remainder.
Exactly.
Until it becomes 0.
Exactly. So until it becomes 0, that is important. So let's say I'll define 2 octal, okay, and it takes some integer, say k. Okay. Now this k. So what is the stopping condition for the recursion? We are supposed to write a recursion here, right? So what is the stopping condition? If k is equal to 0, it will return 0. Okay, that is the stopping condition. Now if k is non-zero, then what happens? then what happens? What do we return? Like what do we call? So every time we need to do a remainder operation, and the rest of the part we need to divide it by 8 and send it forward. Okay, you agree? So if I have a number, say 20, okay, I have a number 20, I want to, or say 200, I want to basically do a 200% 8, okay, whatever remainder I get from here, and then I want to do 200 by 8 and pass it forward. Okay, so 200 by 8 will give you some, how much, like 16, 40, so basically 25, right? 25, and this 25 will again go with the same condition, percentage 8 and 25 by 8 and so on, like, right? And where will this, and remember, for all these conversions it is always saved in a reverse manner. Okay, it's always saved in a reverse manner. So whatever remainder I get from here, this remainder should come before this. It should be before this one. Oh, that is okay. This should be before this one. Okay, does that make sense? Like, are you able to understand? So this is later, this is first, so this should come before this. So if this is say 1 and this is say 5 and here it is 0, okay, what is this? This is 24, this should be 1, right? It will be 1. So basically it should be 1 0, not the other way around. So this should come with a multiple of 10, right? Only then it will come with before this, right? So we just multiply whatever we get here with 10 and then pass it forward. So how you will write it is that return, you will call 2 octal with what? With k by 8, right, into 10 added with k percentage 8. Make sense? So what will happen? So let's let's do a few steps for this, for a value of 200. So I call 2 octal, so this calls 2 octal 25, okay, so it will do multiplied by 10 plus k percentage 8, that is 200% 8, 0, it is divisible, so it is 0. Now this 2 octal what it will do, it will again do 25 by 8. So what it will call, it is non-zero, it is not 0, so it will not return 0, rather it will call 2 octal k by 8, which is 25 by 8, which is 25 by 8, right, multiplied by 10 plus k percentage 8. K percentage 8 is, so k is what here? K is 25, percentage 8, so 1, right, remainder is 1. Now this octal, what it will be? 25 by 8 is basically 3, right, because it's an integer we are talking about, so the decimals you can just ignore, so it is 3. So 2 octal you are calling basically 2 octal of 3. So you are calling 2 octal of 3. So what is 2 octal of 3? So 2 octal of 3 is, again it is non-zero, so k by 8, so 3 by 8. 3 by 8 is 0, because integer, only considering the integer part. 0 into 10 plus 3% 8. 3% 8 would be 3, right? Now 2 octal of 0, what is it? It is 0, right? So 0 into 10 plus 3. that is 3. Okay, now this entire part will return 3 here. Now 3 into 10, so this returns 3. So 3 into 10 plus 1, so that's 31, right? So this part will return 31 here. So 31 into 10, 310 plus 0, so 310. So this returns 310. So now 2 octal of 200 means 200 is 310. You can verify that, of course. But I hope you understand why this multiple of 10 has been done, because you want it to come before. So the last one should come first, right? So this 3, which was the very last remainder, should come to the very first. So every time you need to multiply that with the 10, so that whatever comes will come on the right side of 3. So here we multiplied it, and on its right side the next remainder 1 got added, then here the next remainder 0 got added, and so on, because you need to go in the opposite direction. So you would have done something like this: 200, so 25 with a remainder of 0, again 3 with a remainder of 1, 0 with a remainder of 3. So you go in the opposite direction. So then you can say that base 10 is for base 8, 310 of base 8. So this is how you get. So this is the so this part is your recursion part. Okay, this is the code for recursion from octal, from integer or from decimal to octal. Is it clear?
Yes, sir.
Okay, so that is all that I had for you in this particular session. If there are any particular doubts, you can ask me. I don't see any questions in the chat box, so you can just unmute and ask if you have any particular doubts. So recursion questions, as I said, you have to be a bit careful while solving the recursion questions. It takes a bit of patience.
Sir, in that second slide you shown.
Second slide? This one
Sir,
or
does that,
this one?
sir,
This slide?
is that define a protocol of foo necessary?
Okay, the protocol. Okay, this prototype. You're talking about prototype. Okay, yeah, foo. The foo is not required. Yes, true, because you are defining foo before f. So prototype for foo is not required. Yes. No. Wait. It's required. It's required because see, the execution starts at main. Okay, main. You need f to be defined before. Okay, so it understands that f is. So think about this: the compiler starts from main, or the execution starts from main. It goes and it checks if f is there. F is there. Okay, you have defined a prototype for f. F is there, so it goes to the f part. It checks it prints whatever, and it goes and checks for foo. But actually, the foo is not defined at that point, is it? Because you came from main directly to f. So is foo defined at that point? That's good question. I am not very sure. Like, we have to try this out on a computer and check. Talking from a syntax point of view, it does make sense that you just need to declare a prototype for f, not for foo. But from the execution point of view, it came from main. I have already drawn it here. So from main, it directly went to f. But in f, there is an occurrence of foo, which it does not recognize. because there was no prototype. Okay, so yeah, it might or might not. Yeah, I'm not sure, to be honest. So we can try this out. Okay, yeah, I mean, try it out and find out. That's what I can tell you. Or we can try it out right now and let's do this. Okay, we have a main. I'm just trying it out on my own computer. So it calls the function f. Now we have a void f, which
It's working, sir.
it's working, right? Okay, that's fine. So syntax wise it does make sense. Like I said, syntax wise it does make sense, but if you go from the execution point of view, I had a doubt. But anyway, so it's working. So basically, so the thumb rule is that you have to have whichever function that you are calling inside that particular function defined before it. So here, because foo is defined before f, so it's fine. So you just need to specify the function prototype for f only. That's fine. Alright, yeah, good question. Any more? Anyone else? Okay, if not, then I'll close the session here. Alright, thank you for joining, and we'll meet in the next Tuesday 6 to 8 for discussing questions regarding week 9. So thank you.